Hello, welcome to another content brought to you by Lean6Sigma.net. Today we're going to talk about how to execute an analysis of variance using Excel. I made another video about this particular topic where I cover all the theory behind analysis of variance, and I actually document step by step how to construct the ANOVA table. In this video, I'm not going to take too long. I'm basically going to demonstrate to you how to do it very quickly in Excel. If you like the content, go visit us at Lean6Sigma.net, where we provide information about Lean Six Sigma reliability. You'll see information about our classes, certification, and very important content. I also ask you to subscribe to our channel so that you can be updated as I try to incorporate more information and useful tools to the Lean Six Sigma community. Before I show you how to do this in Excel, first I want to make sure that you understand that before we execute ANOVA, there's a series of things that we need to verify. One of them is stability of the data. When I talk about stability, always remember that the means and variances should not be changing over time. The other step that we need to verify is normality, and the third one is that the data actually has equal variance. Only when these three steps are executed is that you can execute the actual module that exists within Excel. Here's the example we're going to work. A golfer wants to test 4 designs of drivers to see which driver on average hits the golf ball the farthest. He went to the driving range and tested each design 10 times and measured the travel distance in yards. We're going to use ANOVA to determine if there's a difference in the average travel distance for any of the design, and here are 4 designs. The data is presented to you in columns. This is the steps that we took to verify the stability, normality, and variances of this data. It is not the topic of this particular training to show you how to do that. So we're going to then proceed to execute the analysis of variance using Excel, because the data fits those checkpoints. So here's the data. We have a design 1, a design 2, a design 3, and a design 4, and we're interested in testing whether all the means are equal versus at least one of the means is different. To do this using Excel, you'll have to click on the data menu, but sometimes you will see that the actual button where you can perform the one-way ANOVA is not available. So that means you don't have the add-in in Excel yet. So to do that, you're going to go into the file, go all the way to options, and then in options you want to hit add-ins, go all the way down to where it says Excel add-ins, hit go, and then here you want to add the analysis toolpack, and since I'm added, I'm going to add the solver since I don't have it as well, but it's the analysis toolpack, the one that you want. So once you hit OK, then that analysis toolpack is already added. You are going to select the data, has to be selected, and then now this is the button that allows you to execute the ANOVA. You're going to hit data analysis. Immediately this window will show up, and what we're trying to do here is ANOVA single factor. This is what we call the one-way ANOVA, because we have one X with multiple settings of that X. We're going to hit OK, and then it's asking me where is the data. I'm going to tell it that the data is here. This is the range of the data. It is actually in columns, and the label is in the first row. We're going to test this ANOVA using 5% for significance. And I have two choices here to put it in on this same page or to create a new worksheet. I'm actually gonna select an area here of this page where I want to put this data. So I'm gonna select the output range, and I'm going to select right here this area to put it starting on this point. And then from here forward, it's just hitting OK. So at this point, it has executed the analysis of variance for you. It's presenting a summary table with the actual averages right here and the variance for each of these averages. We can see immediately that the averages are different. They tend to increase with the design. Now the ANOVA table is going to tell us if this difference that we see in the averages is actually statistically significant. To do that, here is the ANOVA table. It's going to look at the difference within the designs, and then it's going to compare that to the difference between the designs. It's going to build this F statistic here, and it's going to calculate a p-value. The rule of thumb for this p-value primarily is if the p-value is low, the null got to go. And this is actually the case. Our p-value is practically 0. Therefore, H null got to go. Another way to say this is that there is sufficient evidence to reject that all means are equal. Therefore, we have to settle with the alternative that at least one mean is different. And this is how you quickly execute analysis of variance using Excel. I hope you enjoy this content, and join us in the channel so that you can be updated for future videos about statistics, Lean, and Six Sigma. Thank you.